over.
Okay.
So you watched the video or the TED Talk video on Avogadro and the mole, and we really liked that very much because we think it was as good as we could do, maybe.
Yeah.
Oh, yeah.
On explaining what the mole is. It's a very complicated thing to understand it on the conceptual level. So this is an explanation of how to use it when working with the periodic table. So this is a Kathyism, and I like to talk about atoms and compounds this way. So I like to think of an atom is to an element as a molecule is to a compound. In other words, if I'm talking about an atom of sodium, I take my ice cream scoop, I scoop it into my container of sodium, and I have the element sodium instead of an individual atom of sodium. I have a whole bunch of atoms of sodium.
Mm-hmm.
And a compound is a scoop of molecules. Like if I take a scoop of salt or a scoop of sugar, I've got a whole bunch of molecules of that. And this whole point of talking about the mole is kind of defining what that scoop actually is. So here's the actual definitions that you probably wrote down in your notebook already. Hint, 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 yes. I think there's a lot of learning in writing this into your notebook by hand instead of cutting and pasting. So, and just remember, an element is usually referred to as a scoop of atoms, and a compound is usually referred to as a scoop of molecules or a scoop of that compound. So, we're going to use a periodic table here. Remember, we looked at the periodic table, and we got the atomic weight of each individual atom is on that periodic table, and those units are in AMU. So we look at the periodic table here, we can see that the weight, the atomic weight or atomic mass of lithium in AMUs is 6.941. And the reason we have 6.941 is not a whole number, as you recall, that's the weighted average. Although chemists will just call it the average weight. But you guys all know, right? It's the weighted average. If you need a review on that, go back and review that module. So when we look at the mole, we talk about it as a little bit like as if it was a dozen or a pair. And that's how we're going to use it here. We know the mole is 6.022.1415 times 10 to the 23rd.
A lot of sig figs.
There's a lot of sig figs.
There's even more if we want to look up.
Right. So how many should we actually use?
Well, it's typically 6.02
times
10 to the 23rd.
So there he is again, that cute guy, Amadeus. And the definition of the mole is this complicated sentence. But what we're going to do is just be able to use that mole and count kind of in our heads how many atoms are there. So how many carbon atoms would be exactly in 1 mole of carbon?
Oh, well, we know 1 mole has 6.02 times 10 to the 23rd carbon atoms.
And I like that you have the unit to go with that number.
Mm-hmm.
So,
yeah. And when I write the units, I always like to write in what the element is, because later that will come in handy.
Oh, it will, just to be complete. And whether you use 2 decimals or 3 decimals, I know that in this module we go back and forth using 2 or 3 different decimals. This is a fixed number this has infinite sig figs. So it doesn't matter whether you use 2 or 3 for your calculating down the road. So the molar mass is the mass of 1 mole of anything. We could say it's the mass of 1 mole of eggs. Or the 1 mole of shoes, which I like.
That's a lot of shoes.
That's a lot of shoes. Or the mass of 1 mole of marbles. Some people say I've lost mine, but so we look at the molar mass really in practical terms. It's the molar mass in 1 mole of atoms. So the molar mass of an atom means that we're going to have 6.022 times 10 to the 23 of those atoms. What was that, a sextillion? Sextillion atoms? Let's make it simpler. rather than writing out all those digits, one atom has a mass of 12.01 AMUs, but we can go to our periodic table and take that same number and put grams next to it, and we just know that it's 6.022 times 10 to the 23rd atoms of that element.
Okay, so if I'm looking at a periodic table and I read it in grams, it's up for a mole, and I read it in AMUs, it's for an atom.
Absolutely.
Correct.
So for any element, if you're talking about the atomic mass or the mass of a single unit, you'll be using AMUs. So some of the questions on the quiz is going to ask you, what's the mass of that atom? And the units of a single unit would be AMU. But if you're asked, what is the molar mass? You're going to be using the units of grams. So read all those questions very carefully. Hint, hint. Okay. So, oh, there's that lovely mole again.
Oh, that's the one I caught in my yard last year.
Oh, lovely, lovely. I try not to catch them. So, to determine the molar mass of any atoms, the units for the molar mass of 1 mole of atoms will always be in, together now,
Grams.
So, the molar mass in grams of lithium would be 6.941 grams.
All right, so if we take a look at atomic and molar mass and two different elements on your periodic table here, magnesium and chlorine. So if we look at magnesium and we're looking at the average atomic mass, we're taking 1 atom of magnesium and we're going to see that's equal to 24.305 AMUs of magnesium. If we take 1 mole of magnesium, that's going to be equal to 24.305 grams of magnesium. The same works for chlorine. If we have 1 atom of chlorine, we have 35.453 AMUs of chlorine. Or if we have 1 mole of chlorine, we have 35.453 grams of chlorine.
Those look like conversion factors.
We're going to be using those as written and come up with unit factor to solve a lot of these problems. That's the next module though. Good hint. So now it's your job. Pull up your periodic table. I know you've already got it. You probably got your grocery list written on the back of it. At least you should carry it with you all the time. And look on your periodic table and come up with the mass of each of the atoms shown. Remember to hit pause when we do Thinker Buddy. Okay. Carbon.
Okay, so we have a mole of carbon.
Yep.
Is 12.01 grams. Oh, here, I'll put a little carbon. Or I can write it in the units as well.
Okay.
Okay.
Sulfur.
Sulfur is 32.06 grams of sulfur there in 1 mole. Mercury.
Hg, that was hard to find.
Yeah, it's very heavy. 200.59 grams of mercury in that. Notice that it looks like a smaller amount, but because mercury is so heavy, it weighs a lot. And there will be the same number of atoms in all of these samples.
Yes.
So copper is 63.55 grams of copper, and iron is 55.85 grams of iron.
And I think it's a really good idea to always use 2. Round to 2 decimals. Make sure you round up or drop that last one if you need to. But using 2 decimals, you'll get the right answer in OWL or, most of the time on the quizzes as well. Using 3 or 4 or 5 or 6 decimals, it's going to be a bit of a waste of your time.
Yeah, and depending on the periodic table or your source, you're going to find different numbers of...
Slightly different, yeah, in that great detail. So how many atoms is in 1 mole of each of these samples?
6.022 times 10 to the 23rd.
23rd
atoms.
atoms.
And so all of them
them.
represent the same number of atoms, even though the size looks different because they have different properties. Notice the units are all in grams. So just a quick review. The atomic mass of a single atom are units of AMU. And the molar mass, so as you say the word molar, you're going to have units of grams. So now we're going to look at the molecular weights and formula weights of compounds. This is the mass of one molecule of a substance, a single individual unit of a molecule. So you want to add up the masses and AMUs of each element or ion in the molecule or formula. For ionic compounds, you'll see people who are very technical about that use the words formula weight instead of molecular weight. And for covalent compounds, the term is molecular weight. We're going to be a little lazy and go back and forth with it. Just want to give you the official.
Molecular weight is commonly used.
Very common, yeah.
Yeah. More the engineers use the formula weight and molecular weight.
So Stephanie, would you add up?
Okay.
Show people how to determine the formula weight.
We have sodium, which if I look at the periodic table, I see 35.45.
That's chlorine.
Oh, I'm sorry. Chlorine, you're right.
That's okay. You can do chlorine first.
We
It
can
doesn't
do them
matter.
backwards. I'll write that there so
Yep.
everyone knows.
And this is live.
Yes.
And we
Well,
have
we're live now.
Yeah.
sodium, which if I look at my periodic table, it's 22.99. And remember, I'm adding, so I want to make sure I do those in a column and line them up properly. And then I get 58.44. And these are in grams.
No,
they
that was a good
aren't.
mistake. I'm glad you made that mistake. And look you didn't get hit by lightning. It's okay to make mistakes. We
right.
make them all the time.
Yep.
But remember, we're looking at the mass of one molecule.
Ah, yes.
And the mass of one molecule is going to be tiny, tiny, tiny. So we put the units of AMU.
Yes.
All right. Now let's do the molecular weight of the covalent compound of water.
Okay, so we have, this time I'll do hydrogen first. We have 2 hydrogens, so I have to do 2 times the mass that I find on my periodic table, 1.01. So I get 2.02. And then for oxygen, I only have 1 of those, so I can just add it up and I can line those up.
I like the way you line up those decimals. That's so cool.
And I get 18.02
Wait, what's the units?
AMU.
Because we're looking at one single molecule of water, if you could possibly get that small. But we're not working in Berkeley. I'm using lasers. So we're going to, in general, for a single individual molecule, you're going to have AMUs for your units.
Okay.
So let's look at magnesium chloride. And if we go to the periodic table, we know that we have 24.305 AMUs.
Okay.
But and we know the atomic mass of chlorine. But one thing you have to remember, we need to write the formula correctly. So is a metal present?
Yes.
Yes, it's an ionic compound, so the ions are present. Let's write the formula correctly. So what's the charge on magnesium?
What's the charge on magnesium?
It's in group 2, so it has to be a
2+.
Chlorine becomes chloride ion, and it has a charge of -1. So to write the formula, we do the scoop and loop.
So
Did I say that right?
2,
Loop and swoop.
Loop
and
and
then I
swoop.
take the 2
Yeah.
and put it down there. Take the 1. Put it here, but I don't need to write the 1.
Yeah,
so
they won't let me write the
we
ones.
more commonly see it that way.
Okay. So that means we have 1 magnesium and 2 chloride ions in this compound. So now we can add up the mass of magnesium chloride.
Okay, so if we take our magnesium, we see we have 1 magnesium at 24.305 AMUs.
Okay. This 305.
And then if we have 2 chlorines, so we have 2 times our 35.453, which if we do out the math, we get 70.906 AMUs. And when we add those up, we get 95.211 AMUs.
And that represents the mass of a single individual molecule. If you could do, but you can't do that, but if you could do that, of magnesium chloride. Unit, yes. Okay. So now you have a job. Hit the pause. Really hit the pause. No, really hit the pause and take a minute, pull up your periodic tables, and we're just going to give you the answers. We're not going to tell you how to do it. We're just going to give you the answers.
Good double check.
Okay? All right.
Okay, so the weight in AMU of sodium chloride is 58.44 AMU. For water, we saw that one already, so hopefully that one was pretty easy. 18.02 AMU.
I do like redundancy, though.
Yeah.
Yes.
For methane, we have 16.04 AMU. And for carbon dioxide, we have 44.01 AMU. And then potassium carbonate, you had to write out the formula. So I'm going to go ahead and write that just so you can double check to see if that's where you might have gone wrong, if you got the incorrect answer. And that turned out to be 138.21 AMU.
Okay, great. If you have any questions on how to add up K2, CO, and 3, do each step out like we did the other ones. You know, make your work show each step and then add them all up and see what you come up with. And remember, this is the mass of one molecule of each of the substances, or one unit. So now we're going to ask you, it looks like the same slide, doesn't it? But what's the difference here? We want the
Molar mass.
So you can add them all up all over again, and I think that redundancy would be good practice. Or you can just put those same answers in, but the unit is going to be grams. So what we can also do here is we can actually make these kind of look like a factor. Equals 1 mole. And you could put equals 1 mole to every single one of these, or we could say that, for example, water, go ahead. 1 mole of carbon dioxide, 1 mole of methane equals 1 mole of water.
Hopefully by this point, this seems really boring to you because you get it.
And boring is good. If you're bored, that's good.
I know, that means that you understand it.
Now, we're going to be able, you won't see them written like that in the book. You're going to see them written like that. So we want to write them 58.44.
Okay, so I'll just do sodium chloride
yeah.
as an example. 58.44 grams of sodium chloride per mole of sodium chloride. And sometimes, you will see this abbreviated even more, 58.44 grams per mole.
Actually, you'll see the grams per mole a lot more often because that's a heck of a lot easier to do when you're writing in text,
right,
as opposed to writing in.
But all three of these representations are the same, mean the same thing. So 58.44 grams per mole, 58.44 grams of NaCl over 1 mole of NaCl, 58.44 grams equals 1 mole of NaCl. They all mean the same thing.
Just like we did with unit factor back in module 2. Okay, it's back.
Okay, so if we go back to our example of magnesium chloride, but we're looking at the molar mass of magnesium chloride. So remember, talking about 1 mole of magnesium has 24.305 grams. 1 mole of chlorine has 35.453 grams. So if we want to look at the molar mass, we need to look at our formula of MgCl2. We can see 1 mole of magnesium and 2 moles of Cl. If we multiply them by their respective grams per mole and add them up, we'll get your 95.211 grams per 1 mole of MgCl2.
Hey, wait, but that's the same number we got before with AMU. Couldn't we have just written 95.211 grams?
As long as you're right per mole. Yep.
Yeah, exactly.
So you don't have to do your examples twice. You can just put grams when you're talking about moles, or AMUs when you're talking about individual units.
Correct.